Hi friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if I am audible and visible clearly so that we can get started with the session in a few minutes. Again, we'll start the session itself at 7 p.m. sharp so that everybody can join in the session because the scheduled time is 7 p.m. right? Again, I have everything set up on my phone also just to look at all the comments so that I can keep track of what's happening. Cool. Yeah, so I'm visible and audible, right? Anyway, I'll start sharing my screen in a few minutes. I have the chat window on my computer also. So we'll surely, there is a little bit of notes that I made so that, again, I'll share the notes with you at the end of the session. The notes itself will cover all the details on what you should focus on, what are more important, what are less important, and things like that. Hey folks, thank you very much for joining in today. I understand this is year end for some of you and it's vacation time for others, right? We have a long weekend also. I completely understand that, and thank you once again for joining in the session. Cool. We'll get started with the session itself by about 7 p.m. or so. So I'll try to answer some general questions because the scheduled time is 7 p.m. and we'll wait for everyone to join in. Cool. Yeah, sure. Nabil is asking me to share the notes. I'll surely share the notes at the end of the session. I'll share the detailed notes with all the links that I have in it, and I'll post it in the description section as well as in the comment section of this video itself. I'll do that. Hey, happy new year to everyone. I understand that 2020 has been very rocky for many of us, and yeah, so I completely get that. Hope 21 will be better with the vaccine around the corner. I mean, I hope things will go back to normalcy. So Hemant is asking a question about GANs. So Hemant, we covered basic foundational mathematics behind GANs as well as a whole full-fledged code, right? So we implemented a GAN from scratch using TensorFlow gradients, and so this is one of the sessions that we've done. It's available in the course videos and in the live sessions. In case you missed that, please check it out. Again, the most important thing about GAN is the core concept itself, as well as, so we try to implement a CNN based GAN, basically an image generator, right? From scratch in TensorFlow, because that's the best way for you to learn, as I will anyway tell you in this session. So that's one thing. Of course, there are more advanced forms of GANs that we will surely cover in live sessions. Again, the core purpose of the course that we have designed is to help students transition to careers in machine learning and AI. I completely get that. Most of you might already understand that. So we are avoiding going too deep into one topic unless there is a market need for that skills. We cover GANs. We even implement GANs from scratch. Of course, there are like 100 variations of GANs in research papers. We may not be able to cover all of it, but in live sessions, we are trying to cover some of these state-of-the-art techniques. For example, recently we did a live session on GPT-3 and things like that. So again, folks, please understand that we may not be able to, again, this is like one versus, there are already 200 folks in the live session. I may not be able to answer all the questions, but I'll try my best to answer as many as possible. And in case I miss any, you can always email us at team@applied course, and we are there to answer your questions as best as we can. Cool. So, okay, I'm just scrolling through the comments, and I'm randomly trying to pick. You want me to increase the microphone volume? Okay, just give me a second. Okay, so I think the microphone gain might be slower slightly. Okay, I'll increase the microphone volume. So those of you whose volume was already high, you might want to decrease it. I just reduced the gain on my microphone so that it's easier for everyone to hear more clearly. I hope this is better now. Okay, so is the volume better now, folks? Because some of you suggested me to increase the volume. I increased the gain on my microphone. Is this better now? So Reva is asking, can freshers like us get into Ernst & Young? Yeah, we have students who are freshers, even working professionals who joined Ernst & Young as data scientist roles. I heard recently news that Ernst & Young is trying to start hiring large number of data science professionals in India. And we already have a relationship with them because they've hired our students and those students have excelled. So that's something that we are very sure we can do well on. So cool. So okay. So Ryan is asking an interesting question. What do you say about Fast AI course? It's a good course, no doubt about it. I mean, I think Jeremy, who is one of the founders of FastAI course. It's a fairly well done course. I mean, I really liked it personally. So I like a lot of courses. Again, we learn a lot from other courses. I learned a lot from how to teach better, how to design the course better, how to design assignments better, how to do code dive deeps. All of these we learned from multiple courses, and we're always looking for new ideas, and FastAI is a great source from which we learn how to do our courses better. Cool. Okay, good. The volume is good. So very good. Shravan asks a very good question. In Applied AI course, you focus a lot on Python, but some companies also ask for R. That's true, Shravan. Not every company would want you to use Python. There's no doubt about it. But the fundamental limitation with R, again, that doesn't mean that the company says you have to only know R, right? So most companies, if you know Python, they will still consider you because they understand that somebody who knows Python can pick up R. Right? Again, R is easier in some ways than Python. But the reason we focus so much on Python instead of R is because Python has more libraries and it's more widely used in production environments. I'm not saying R is not used. R and SAS are also used, but the proportion of companies is fewer. Okay, that's the reason we focus more on Python. So Arf asks a question, Arf Khan. Which is best, KNN or t-SNE for human action recognition? Neither of them. I think you need to understand this. Human action recognition is a computer vision problem for which the state-of-the-art techniques are all based on convolutional neural networks, right? So that's one topic that we are going to do a live session on soon, which is given. Imagine I have a photo and I'm raising my hands like this. Can it recognize all the limbs, all the joints in my body, so that it can recognize my action? So that mostly comes into computer vision. Of course, state of the art in human action recognition is done using convolutional neural networks and not much of KNN or t-SNE like techniques. Cool. 1 second. So somebody's asking. I think somebody mailed us also about TinyML. It's a nice point. I'll just cover that and we'll start the session. All right. So as far as Anupam has a very good question. So TinyML, right? It's a very nice area. Again, I like the naming because this name didn't exist just a few years ago. TinyML is all about taking machine learning and deep learning algorithms and placing them in low-end compute devices. Like for example, imagine, nowadays smartphones have become terrific. They're almost as powerful as your laptops and desktops, especially with Apple A13, A14 chips, also Qualcomm 865, I think 875 is also out. But imagine you have an Arduino board, an IoT chip, right? So there is a live session that we did. I think it's called Machine Learning for IoT. It'll be there on our channel if I'm not wrong. So you can check that, where we talk about how you can take a machine learning or a deep learning algorithm and port it to a low-end device like an Arduino or a ESP32. These are all microcontrollers, which so these are all very simple, cheap, or Raspberry Pi, right? These are cheap microcontrollers which are used in IoT devices. So the best part of that is, of course, you can implement everything from scratch in C or something. That's one way of doing it. The other way is TensorFlow itself. You can take a TensorFlow model, and TensorFlow has something called as TF Lite. Again, we'll be doing a live session on it hopefully in Jan or early February of next year. Oh, we're already in the end of the year. So yeah, of 2021, that's what I mean. Where we will take a TensorFlow, let's say a convolutional neural network model. TensorFlow has this very nice mechanism where you can take a TensorFlow model, convert it into a TF Lite model, and deploy it on a mobile phone. You can deploy it on Arduino or any IoT device. That's what TinyML is all about. If you know core machine learning, deep learning, all of these concepts, TinyML is just a simple extension to it. And thankfully, of course, understanding, again, if you're coming from an electronics or an electrical engineering background, understanding microprocessor architecture, microcontrollers, computer organization certainly will help you design these things better, right? So, but if you do not come from that background, there are pretty good tools and pretty good libraries. Again, you can write the code yourself in a low-level programming, or I can't call it a low-level programming language, in a programming language like C, right? So that's possible. Cool. So let's do one thing. Again, the very interesting questions from people like Bitu, which is importance of mathematics. So let me do one thing, folks. What we'll do is, since it's 7:02 p.m., I have some notes that I've written on what are the most important aspects. So let me try to cover these. Probably I'll take about 45 to 50 minutes to cover these. Once I finish that, the floor is open for a general discussion. Okay. So is that, I think that methodology is better, because many questions that you're asking, I would have covered them in the notes that I've written. Okay. Then I'll surely come back. We'll have a general Q&A. Okay. As usual, that will be more beneficial, because I can cover the broad topics first. So let me start sharing the screen. Okay. So I think everybody can see the screen now. Okay. So let's go here. So can you just confirm if you can see the screen? Just wanted to make sure that everybody can see the screen. Let me also see it on my phone, just to make sure. Everything is working. I've just changed to my screen. Can everybody see my screen? Okay. Can everyone see my screen? Can you? Okay. I think I can see my screen on my phone. Yes. So you can see. Okay. Cool. So let's get into the discussion, and then we'll finish the core discussion topic itself, which is how to best learn AI machine learning in 6 months. There is a reason why I put this number as 6 months, because if you put consistent and persistent effort, you can go a very long way in 6 months, worst case 9 months. Okay. So we see a lot of our students who are putting in consistent effort, from freshers to experienced professionals, complete everything in 6 to 7 months. Okay, cool. So let's go into it. Again, this whole lecture is not specific only to applied AI course. Wherever you are learning AI and machine learning from, we wanted to give you a general guidance. This is not just about applied AI course or only our courses. It's about general guidelines. Of course, I will keep pointing you to some public live sessions that we have done, pointers and things like that. Cool. So first and foremost, it's a very common question. What are all the roles that are there, and how are these roles different from one another? Okay, it's a very good question. First, let's understand broadly there are 4 types of roles. I'm not saying there are only 4 types of roles. There are other types of roles also. Okay, so broadly speaking, there is this data analyst or a business analyst or a business analyst in data science type of role. Then there is a data scientist type of role. Then there is a machine learning engineer. Sometimes instead of a machine learning engineer, you'd have a computer vision engineer or an NLP engineer or an AI engineer. Then there is an applied scientist. Sometimes these are also called as research scientists. Broadly, these are the 4 categories of jobs that you have. Again, some companies might have a slightly different nomenclature of naming things. Okay, but broadly speaking, these are the 4 categories that you will encounter. Now, okay, let me explain you how they're different. So let's start with applied scientists. Again, in terms of compensation, applied scientists are some of the highest paid. And for an applied scientist, the expectation is, again, there are 2 broad angles on which any machine learning, for any data science or machine learning role, you'll be tested on. You'll be tested on your mathematical rigor, everything from foundational mathematics to advanced deep learning techniques. And you'll be tested on your coding skills. Okay. So for applied scientist roles or for research scientist type of roles, which are different from data scientist roles, the expectation on your math front is high to very high. Again, if you interview at top product-based companies, they would expect you to know the math inside out. Okay, they would expect you to even modify the formulation of problems and work out when the problems are modified fundamentally at a mathematical level. When I say math, I mean the foundational math required for machine learning and data science roles, as well as the math that is underlying most machine learning and deep learning techniques. That's what I mean by this. Okay, just let me check if there are any issues or complaints in the chat window. Okay, so cool. No complaints whatsoever. So everything looks and seems clean. Okay, cool. So now coming back to this, right? So for an applied scientist, you have to be very, very strong on the mathematical foundations as well as the internal mathematics of every machine learning and deep learning technique. And oftentimes you're expected to be able to change the formulation and work out the details in an interview. On the coding front, the bar itself could be between low to medium. So when I say high, I mean it's really high to very high sometimes. So on coding front, depending on your background, imagine if you're coming from a non-CS background, they would expect you to be able to write basic code right? They may not expect you to know data structures algorithms very well. But if you come from a computer science background or a software engineering background, they would expect you to know the basic data structures, and the hardness of questions themselves are low to medium. Okay, so your interviews will focus for an applied scientist role more on math, significantly less on coding. Now the next type of role is called machine learning engineer. This machine learning engineer is a role that is very, very well suited for people who are already from computer science background or software engineers. Okay, people who already have software engineering background, or people who come from or IT experience, or people who come from computer science background. For those people, machine learning engineer is the most apt role because there is significantly more focus on coding. Okay, so machine learning engineers are expected to know like multiprocessing, multi-threading, core computer science concepts, core software engineering concepts. The math expectation for them compared to applied scientists is lower, which means their expectation on the math is, yeah, you should know some of the stuff, but we are not expecting you to know to the same mathematical rigor that an applied scientist is expected to know, right? So so a machine learning engineer role is mostly suited for people who are coming from computer science background or software engineering background. And even in the interviews, you will see much more focus on coding. Of course, so in this probably you will have, let's say, 4 to 5 rounds of math, 1 round of coding. In this case, you might have 3 rounds of coding and 3 rounds of math and machine learning. When I say math, I mean it includes machine learning. Okay. Then there is a data scientist role. In the data scientist role, the coding bar is low to medium. Again, depending on your background. If you come from CS background, they'll ask you slightly harder questions. If you come from non-CS background, they'll ask you easier questions. The math itself is slightly on the medium front. So for a machine learning engineer and data scientist, the math that is expected is roughly the same. And it is certainly easier than the math expected from an applied scientist level, right? The coding expected for a data scientist is surely, the expectation in terms of coding is less than a machine learning engineer. And it's somewhat similar to what an applied scientist is. Now there is one more role, which is data analyst. For a data analyst, the expectation in terms of code is low. The expectation in math is between low and medium. Again, even in terms of compensations at most companies, your applied scientist typically gets the highest compensations. So there are cases where machine learning engineers also get very similar compensations to applied scientists. So 1, 2, 3, and 4. This is the typical order of compensations also, right? And again, people can join, again, you might ask, okay, for a non-CS person, what are the best roles? For a non-CS person, the best roles would be data analyst and data scientist roles for people who come from non-IT, non-computer science background. But if you come from non-CSE backgrounds, but if you're very strong in mathematics, then applied scientist is also game, right? Machine learning engineer role is something that is more well suited for computer science or software engineering professionals. Again, these are general hiring bars. I'm not saying this is true for at every company for every role. That's not true. This is the general bar that we observe across multiple companies, right? But again, we have seen interviews where data analysts are asked slightly harder questions than data scientists. So again, these are general guidelines that we're talking about. In general, the expectation from the interviewer or the company for applied scientist role in math is the highest. In coding, it is highest from machine learning engineers, right? So these are broadly the 4 categories that most jobs will fall into. There are exceptions to this. There is something called as a research scientist. Very few roles exist of that sort. Again, sometimes the machine learning engineer can also be called a software development engineer machine learning. Okay. So research scientists typically come with a PhD in machine learning or in deep learning. So there are very few roles also in the industry of that sort, right? So broadly, these are the roles, and I'll try to explain the expectations for each of these roles in each of the topics. Okay, I hope this gives you a good sense of what is it that companies are expecting. Again, this is a generalization. This is like there could be companies which ask more code for data scientists than machine learning engineer. So this is just a broad overview of roles that you will encounter. Cool. So let's go topic by topic, right? So what is it that you should focus on in programming? What is it that you should learn on programming? Again, very often programming is used as a way to measure your problem solving skills. Oftentimes, most companies use programming. Again, there are some companies which also have aptitude rounds, right? Aptitude could be typically like your, again, the aptitude and reasoning questions could be anywhere from your 10th class mathematics level to CAT level, right? Again, if you look at CAT entrance examination, right? CAT entrance examination has most problems which require only 10th class math. But more and more, again, there are very few companies that have an aptitude round, very, very few, literally a handful of them. Most companies test your problem solving and aptitude skills through programming. Because in a single, so they might ask you a simple programming problem, and if you solve it and write code, they can test that you can solve problems, and they can also parallelly test that you can write code. Again, Python is the most popular, but there are companies which ask for R also. But more and more over the years, Python has gained much more popularity because there are more libraries available. So in terms of data structures, you should know the inbuilt data structures very well. No doubt about it. And of course, one more very important thing here is you should understand basic computational complexity, right? You should understand what is the time complexity, what is the space complexity, basic concepts. We are not expecting you to be an expert at it, but you should know the basic concepts of what is the time complexity, what is the space complexity for the code that you have written. And then again, if companies want to make the programming problems harder, as you go more and more towards product-based companies, they would start asking questions which will involve recursion. So within programming, generally being able to write if-else loops, for loops, right, is surely mandatory for almost every role. But as the level of the company increases, as a company becomes more and more product-based, they will ask you more questions which will require you to solve it using recursion, which is also called divide and conquer approaches in computer science. Right? And again, as you go more and more to product-based companies, they'll start focusing more and more on computational complexity. One brilliant way to really become good at programming is implement inbuilt functions. For example, in Python, right, there is this function called math.pow, which computes x power y. So you can give two numbers, x and y. It will compute x power y. Now we all use it a lot in Python. Now, my suggestion to you is, if you really want to become a good problem solver or if you want to become good at programming, one of the simplest ways is look at all these inbuilt functions that you are using on a regular basis and try to implement them from scratch. How would you implement x power y? It's a very good problem. I used to ask this interview question at one of the FANG companies that I used to work at. Right? I actually used to ask this, like, even to computer science students. Right? Even to like really good CS folks from top universities of the world, I would say in one of the programming questions, I would say, hey, how would you implement x power y? It's not trivial, by the way, right? So similarly, there is this function called, there is this very popular library called pandas, which is used extensively in data science. In pandas, there is this function called merge, which will merge two tables that you have. Now, this is another very popular question that I used to ask at one of the FANG companies, which is, how do you merge these two tables, right? So a great way to improve your programming skills is to implement those functions. Again, these are all data science and mathematically related functions. Pandas.merge, again, pandas is a brilliant library for data science applications. Now here you're thinking on how to apply this merge function, how to implement x power y. So implementing these inbuilt functions will give you a lot of exposure, lot of practice also. In addition to it, you should know the basic libraries. Again, there are thousands of libraries which are used in data science and machine learning, and nobody can become expert at anything. Nobody can become expert at everything, right? Again, even to become expert at one library is hard. Like I use pandas, I use NumPy, I use matplotlib. These are, but I can't say I'm an expert at pandas. No, if I get stuck, I go read the official reference manual of pandas and try to understand what's happening. Right? So you should know at least the basic libraries. NumPy is for numerical computations, Matplotlib is for plotting, Pandas is for data operations. So know the basic libraries. You don't have to know everything, but you should know at least some of the basic things that are most widely used. Again, whenever you're writing any code, many companies have the screening tests or coding tasks or coding tests. One of the things that they're looking for is, are you handling all the boundary cases? Right? For example, if you're implementing math.pow to compute x power y, do you handle the case when y equals to 0? Are you handling this case? Or are you handling the case when x equals to 0 and y equals to 0? Okay, are you handling the case when y is less than 0? Are you handling the case when y is not an integer? Right? So try to handle all these boundary cases in your code. Right? Your function may not do everything, but you should handle these boundary cases gracefully. Okay. So for programming, the most important thing here is to write clean code, write clean boundary cases. The best way to practice, I would recommend, is to implement some of these functions as part of your practice. Okay. Again, at Applied AI course, we have some of these as assignments. Okay. Because that's one of the best ways to learn how to actually write good code. Right? Again, we have a live session that I'm linking to here. I'll share this whole document with you at the end of this session. So this live session itself talks more about, okay, let me just see this live session. Let me click on this. If I recall well, okay, so this live session here, yeah. So this live session is interactive interview session on Python programming for ML and AI. Okay, so we have done a full-fledged, I think a 2-hour live session on what sort of problems you can expect, Python related stuff in real interviews from services companies to top product based companies, right? Again, we try to cover various problems. Okay. So again, please understand that the best way to practice is to implement some of the inbuilt functions. If time permits, you can go to any of these popular platforms like LeetCode, Geeks for Geeks. Start with easy problems. Okay. Because remember, except when you are a machine learning engineer, the expectation in terms of coding is low to medium for all other roles. Okay, in terms of coding. So as long as you can solve simple, easy problems, and if you can solve even a few medium level problems on LeetCode or Geeks for Geeks, that's pretty good. Your practice is fairly good, unless you're looking for a machine learning engineer role where they might ask you more. So for example, imagine, okay, so I've put that case here also. Imagine you come from a computer science background or a software engineering background, and if you're interviewing at a top product based company, Amazon, Google, etc., and you're interviewing for a machine learning engineer role, which is more apt for computer science students or people with software engineering experience. For those people, or even for experienced software engineers, you're expected to know more than just a regular fresher or a non-CS student or a non-IT student. Okay, there could be one round which focuses more on data structures and algorithms. Sometimes the data structures they'll focus on will be simple stuff. Again, even in machine learning, we use data structures like trees. What is a decision tree? A decision tree is like sort of, one of the simplest variations of a decision tree is a binary tree, right? Similarly, you have a hash table which is inbuilt into dictionary. So there could be some questions on data structures and algorithms, more so if you are applying for a machine learning engineer role at a top product based company. And they would expect you to know concepts like multi-threading, multi-processing, etc. If you come from a non-CS background, they might excuse you for that. But if you come from a CS background or if you're a software engineer, they would expect you to know some of these basics, especially at top product based companies. Cool. So this is the expectation from programming. Now let's go to SQL. This is very, very important. It is critical for almost every role, whether it's data. Again, it's more critical for these 3 roles than for applied scientist roles. For applied scientist roles, I've been in interview loops where the candidate is a PhD in mathematics. We hire them even though he or she doesn't know SQL. That's okay. But for data analyst, data scientist, and machine learning engineer roles, this is critical. You can expect a full-fledged dedicated round just for SQL. In reality, this happens a lot, right? So companies just have a dedicated round for this. Let me just check the chat window to see if there are any glitches. Okay, so I'll come there. So this is so in SQL itself, what you should be able to write comfortably is nested queries. Okay, if you can write nested queries, slightly more contrived, complex queries, you're good. If you really want to get a sense of what type of queries you should be able to answer, we have this whole interview called SQL for data science, machine learning, and SDE, software development engineer interviews. I'll provide the link here where we have covered multiple problems from easy to hard. Okay, a simple rule of thumb is in SQL, can you write nested queries? If you can, you're all set for data science, data analyst, data scientist, and MLE roles. Again, remember, especially for data analyst and data scientist roles, SQL is given much more priority, because you might say, hey, I'm not a computer science student, but you're expected to know SQL well, right? So SQL is often used to test problem solving skills for data analyst and data scientist roles. Again, very, very importantly, please don't think that if you join in a data analyst role, you will stay in the data analyst role. I've seen a lot of folks in my own professional experience who get promoted from data analyst to data scientist. I've seen people who go from software development engineer to machine learning engineer roles. I've seen people who go from software development engineer to applied scientist roles. I've seen people who go from data scientist to applied scientist roles by building the gaps and skills that they may not have. For example, on the math front, if you're medium and you join a company as a data scientist, you can improve your mathematical rigor and move into an applied scientist role through an internal review process or an internal interview process, right? So these are not fixed. People move between these roles a lot in the real world. Cool. So again, SQL is super important. In SQL, the test is, can you write slightly complex nested queries? That's the key test. That's the level you should be comfortable with. Next comes all of the data analysis and foundational mathematics. Lot of people ignore this, but this can be a make or break thing in many interviews. You will typically have 1 or 2 rounds of interviews on these topics, oftentimes, sometimes more. Especially for a data analyst and a data scientist role, you will have more and more. You might have just 2 or 3 rounds of just data analysis, foundational mathematics, etc. In this, plotting is super duper important. I mean, you have to know all the top types of plots, how to clean the data, how to pre-process your data. If data has missing values, how do you handle that? So all of the data pre-processing, cleaning, plotting, there are tons of types of plots. Of course, you don't have to know everything, but you should know at least the core ones. What is a PDF? What is a CDF? What is a QQ plot used for? Some basic stuff you should know. Similarly, probability and statistics. I mean, oftentimes I've seen a lot of companies which have a dedicated probability and statistics round or rounds, right? For example, again, we have a live session on this where we have solved a bunch of interactive problems in probability and statistics, which is there on our YouTube channel. So for example, somebody could give you a problem which requires you to apply Bayes' theorem. Can you solve it? Again, I worked in some teams where one of the lead interviewers would say, hey, if a candidate can't solve a Bayes' theorem problem, he's not ready for data science roles. Similarly, there could be questions on hypothesis testing, p-value, right? Various hypothesis testing mechanisms, non-parametric hypothesis testing and things like that. So you have to be fairly comfortable with basics of data analysis. Most of the concepts in probability and statistics, these are foundational. You should know distributions, you should know conditional, I mean, of course, if you know Bayes' theorem, you know conditional probability and things like that, right? So very, very important. You should know a little bit of non-parametric statistics also. Then comes data visualization. Again, data visualization and plotting can be slightly interchanged, but there are more advanced visualization techniques like T-SNE, etc. that you should also know because they're more widely used in the industry. Similarly, on the foundational math front, you should know linear algebra. Again, I've seen companies have almost dedicated round for foundational math where they focus purely on linear algebra, right? You should know equations of hyperplanes. You should know what is principal component analysis. You should know what is singular value decomposition, core mathematical concepts. Okay. And the depth to which you have to know these concepts will increase if you are interviewing for an applied scientist role or for a data scientist role. Okay. Sometimes for some roles, just an intuition of PCA, an intuition of SVD might be enough. But for other roles, they will dig deep into the mathematics, right? I mean, this is super duper important. I've been in interview loops where if a person performs well in these rounds, we just hire them because they have the mathematical foundations to pick up machine learning and deep learning as and when they need it. Another very, very important topic is numerical optimization. Okay, suppose you have, again, this boils down to basic minima, maxima, gradient descent, stochastic gradient descent, and all the sorts of algorithms, right? Up to Adam optimizer in your deep learning, right? So you have to get comfortable with all these optimizers which are most widely used in machine learning and deep learning. Of course, non-parametric statistics is good to know. If you know it, it's great. If you don't know it, it's still okay. For example, non-parametric statistics, the simplest stuff would be median, percentiles, quantiles, IQR, right? Simple stuff. To more complex hypothesis testing using non-parametric statistics, etc. So again, what I'm listing here is the bare minimum. The more you know, the better any day. Okay, nobody will penalize you for knowing more, but these are the bare minimum stuff that you should know. Now, in these techniques or in all these concepts, what are the stuff that you should focus on? For example, these are some of the most important things that you should focus on, because we see some students who know these things, but we can't answer these fundamental questions. For example, what technique to use where. Where do you apply this technique? I ask these questions. Okay, I often ask this. So when you're learning about a technique or even a simple plotting thing like a probability density function or a CDF, right? These are very simple plot techniques. I would ask, hey, where do you use a PDF and where do you use a CDF? Okay, very simple questions. And pros and cons of each of these methods, from plotting techniques to statistical tests. Like some people say, hey, I'll use a t-test. I'll say, hey, where does t-test fail? That is nothing but the limitation or con of this test. Right? Some people say, hey, I'll use a chi-square test. I'll say, hey, what are the advantages of chi-square test and where would it fail? Right? Those are very, very important stuff that you have to know. So you have to know where to use which technique, what are the pros and cons of each technique, what are the limitations of techniques. You have to be comfortable explaining the math. For example, if I ask you, okay, can you explain me about a metric like KL divergence in probability? Or I ask you, can you explain me Kolmogorov-Smirnov test? Okay, or I can ask you, can you explain me the underlying mathematics between t-test or chi-square test? Can you work out the math from first principles? Right? Because if you know the underlying math, the chances that you'll crack interviews is more. This is one place where lot of learners lack. If you don't know math, you're not prepared for a data science career. In the long run, you might get in the initial days, but slowly you will not improve. Equally importantly, my suggestion to you is, because you have learned the basics of programming, right? When you learn a new concept, try to implement it from scratch, because that will improve both your programming ability and your conceptual ability. For example, let me give you a simple example. This is a question that I used to ask at Amazon myself. Okay, so people say, hey, very simple question. Okay, can you write a function to which I will give some data? Okay, I'll just give a list of data. Can you write a function which will plot the probability density function? I mean, this is a non-trivial question, right? What we do a lot in practice is we'll just use Matplotlib or Seaborn, one of these libraries, to plot the PDF. But my question is different. The reason interviewers ask these questions is because in one question, I can understand whether you know the internals of PDF. Do you know the underlying math behind PDF? And can you write code? In one question, I'm shooting two birds. I'm testing your programming skills. I'm testing your underlying math knowledge also. In a single question, I'm doing both. Right? So these are also very, very popular questions. And if you can implement a technique from scratch, you will never forget it. That's why at Applied AI course, in our assignments, we make students implement some of these techniques from scratch. We make them implement a logistic regression with regularization from scratch, because that's the best way to learn it. Again, very, very importantly, you should know where not to use a technique. And this comes primarily from the limitations of each technique. Equally importantly, you should know answers to why. Why is, again, you might say, for example, take anything, right? For example, for probability, take any concept in probability statistics, right? For example, you have a t-test, okay? I can say, hey, why can't t-test be used in so-and-so situation? Or why can't chi-square test be used in so-and-so situation? Why is permutation testing required in this situation? Or why are you using a median and a percentile? Why are you not using a mean or a standard deviation or variance, all this stuff? So you will encounter a lot of questions on why you're using it, why you're not using it, why this is so. These why questions can increase in complexity a lot, right? Because these why questions can go to again, you'll be able to understand more and more of these whys if your underlying math is strong. Okay, so whenever you are understanding the math, ask yourself this basic question. Whenever you see any equation, you should ask, hey, why is this equation like this? What happens if I change this equation? Those are very, 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 very important stuff that you should focus on, especially in the foundational math and data analysis. So now comes classical. So once your foundational math is covered, right? Once your foundational math and data analysis is covered, then it all boils down to classical machine learning techniques. Again, there are hundreds of techniques. What I'm listing here is the bare minimum that you should know. Okay, these are bare minimum stuff that you should know. I'll tell you what you need to know about each technique. You should know, of course, k-nearest neighbors, logistic regression, linear regression, support vector machines, both the linear version of it and the kernelized version of it, basic decision trees, random forest. Random forest is nothing but your bagged models. Then gradient boosted decision trees, very important libraries like XGBoost, CatBoost, etc. Then how do you perform regression using decision trees? How do you perform regression using SVM? How do you perform regression using KNN, regression using random forest, all of that stuff. Basic clustering techniques, k-means, hierarchical clustering. The more you know, the better always. There is no limit to how much you can read. Okay. I mean, I believe that even after working in this field for close to what, 12, 13 years now, what I know is just like less than 1% of techniques that exist in research community, right? But these are the bare minimum. You should know basics of matrix factorization. You should know recommender systems. These are all classical machine learning stuff that you should be very, very comfortable with. And in each, again, if you know more, always better. There is no doubt about it. But these are basic stuff that you should certainly know. Again, if an interviewer asks you a technique that you're not comfortable with, you can say, hey, I don't know this, but I know something related to this. For example, in all these techniques, you should surely focus on the underlying math. I cannot emphasize this enough. If you know the math, you can answer most of the why questions. Again, when you're learning the math, ask yourself, why is this being done like this? Try to derive everything from first principles. Okay, we tell this to all of our students at Applied AI course also. For example, let's assume you learned logistic regression. Okay, then you learned all the math. Okay, very good. Take a piece of white paper. Try to derive everything from first principles, which means don't make any assumptions. Try to derive whole logistic regression either using principles of probability or principles of linear algebra and optimization. Derive everything, and at any point, very likely you'll get stuck. That's perfectly okay. Ask yourself, why is this being done like this? Right? For example, why are we using L1 regularization? Why not L2 regularization? Okay. Again, a very, very popular question that I used to ask from top university students, from even PhDs from machine learning from top universities is, hey, we use L1 regularization and L2 regularization, right? Why don't we use L4 regularization as much? Why don't we use L.5 regularization as much? It's a very, again, these why questions, you can make them very, 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 very complex as you want. So always try to understand the math, derive everything from first principles on a piece of paper, because that will give you the mathematical rigor and depth. Okay, if you have depth, you can crack not just data scientist roles, even applied scientist roles. If time permits, try to implement at least some of these techniques from scratch. For example, let me give you an example, right? If time permits, again, KNN is very simple to implement. You should be able to implement it. There are some specialized data structures related to KNN. Okay, especially if you're interviewing for a machine learning engineer role, they might ask you about KD trees, which is a very popular data structure used with respect to KNNs. They might ask you about locality sensitive hashing. So knowing machine learning specific data structures and algorithms is very useful. Again, especially for machine learning engineer roles, you'll get questions related to this. Try to implement at least one of these. Implement either decision tree, random forest, or GBDT, one of these. Okay. Again, in one of the interviews, when I interviewed at Amazon, in one of the interviews, my interviewer said, explain me how derive GBDT from scratch. And he would stop me everywhere and say, hey, why are you using this? Why are you doing that? Why are you using pseudo residual? Why are you doing that? Why are you not doing that? All that stuff. Okay, because he wanted to see, because I used GBDT in another project that I did just before that, he wanted to test if I really understand this inside out or not. Okay, try to implement some of these things from scratch. When I say from scratch, don't use scikit-learn. Of course, knowledge of these libraries is always helpful. You should know these basic libraries, whether it's XGBoost, scikit-learn. More libraries, the better always. But try to implement it from scratch without using scikit-learn and other stuff, because that will give you the confidence that you know the underlying math and you can change it, right? So that's very, 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 very important. Similarly, you should know about bias variance trade-off of each model. What is the computational complexity of training? What is the computational, or what is the time complexity at runtime? Basic stuff you should understand about every technique. Similarly, for each technique in the real world, how would it behave? Imagine if the data has outliers, how would this model behave? Or how would you make the model work if there are outliers in the data? Imagine if you have imbalanced data, how does this model work? What if the dimensionality of data is large? Would the model even work? What are the best feature transforms you can do so that this model works well? Similarly, what all metrics, right? Again, metrics is a very, very important topic in classical machine learning. What all metrics would this model try to minimize or maximize? Right? Very, very important concepts. These are, again, understanding the models inside out, being able to implement them from scratch is very, very important. Of course, knowledge of libraries is important, but so is answering, okay, what happens if your data is imbalanced and you're trying to train a logistic regression model, or how do you fix it? Right? So all these are fundamental questions that you should be able to answer. Again, equally importantly, for every machine learning technique you learn, you should know what are the limitations. What is the optimal scenario in which this will work very well? What are the techniques? You have to also know where not to apply this technique. It's always good to know some slight variations of these techniques. Okay, for example, let me give you an example. You know logistic regression with L2 regularizer. You should ideally know logistic regression with L1 regularizer also. Okay, knowing at least one or two variations of these techniques is very, very helpful. Suppose you know k-means. Do you know k-midioids? Okay, simple variations are good enough. Equally importantly, try to apply them on real world data. There is so much of real world data available on platforms like Kaggle. Just pick up a problem from Kaggle and just try to apply all the techniques you're learning using libraries or your own implementations on this data. That will give you a lot of clarity on how to apply them. So what you need broadly is you need foundational understanding of the mathematics. You need to be able to implement it. You need to be able to understand things like computational complexity, bias variance trade-off, or overfitting, underfitting, what happens in various real-world situations, and the limitations and variations of techniques and where to apply them and how to apply them in the real world. These are very, very important for most, again, for data science, machine learning engineer, and applied scientist, these are mandatory. Okay. Similarly, deep learning is a vast field, right? There are literally thousands of architectures, but there are a basic stuff that you should know in late 2020, early 2021. Again, this changes from year to year as more techniques become popular. For example, now you should certainly know basic multi-layered perceptrons, backpropagation algorithm. Like I've been in so many interview loops where the interviewer just asks about backpropagation, right? Just basics. He'll take a function and say, hey, how does backpropagation work with this? Okay. Similarly, you should know convolution neural networks, everything from basic AlexNet, at least up to ResNets. If you know more models, that's better, right? This is the bare minimum that you should know. When it comes to recurrent neural networks, you should know LSTMs, GRUs, bidirectional LSTMs. Of course, you should know autoencoders, right? All this, how word-to-vec works internally. Similarly, attention mechanism is becoming more and more popular, both in NLP, slowly in computer vision also. You should know transformers, BERT and GPT models, and GANs. Right? At least this is the bare minimum you should know. The more you know, the better it is. No doubt about it. There are some specialized architectures also, like for one-shot learning and all that. If you know them, it's great. But at least this is the bare minimum that you should know. Okay. Again, for each of these techniques, you should know all this. The underlying math, try to derive it from first principles, implement from scratch, learn libraries. Again, there are broadly 2-3 libraries that are very popular in deep learning, right? So there you have so for example, you have TensorFlow, right? You have TensorFlow. Again, Keras is more or less incorporated into TensorFlow. Then you have PyTorch, right? These are two broad libraries. At least know one. If you know one, picking up the other is fairly straightforward. Suppose if you know PyTorch, learning TensorFlow is very easy because you have the conceptual understanding of things. If you know TensorFlow, PyTorch is again very easy to build. At least know one. Knowing more always helps. But remember, becoming an expert in all of them is also very, very hard, takes time. In 6 months, we can't pull it off. Again, some of you might be thinking, hey, how do I learn all this in 6 months? I'll come up with a timetable for you. A crisp, clean timetable. Just give me a few minutes. Now, again, you might say, hey, I want to pick up specialized topics like computer vision. Right? So if you want to excel in computer vision, again, most modern computer vision is deep learning focused. There is non-deep learning focused computer vision also. I'm not denying that. But state-of-the-art computer vision is all deep learning focused using some variations of convolutional neural networks. For example, take image segmentation, or take object detection, or take image generation using computer vision based GANs. Right? So if you're looking for a career in computer vision, you should know at least the basic types of problems in computer vision and various techniques for this. For example, for object detection, you should certainly know YOLO, V1, V2, V3s, right? Because you want to focus on computer vision, you should certainly know these basics, if not everything else, right? Similarly, if you're looking at segmentation algorithms, you should know things, at least the basics like units. The more you know, the better it is. At least the basics you should know, right? Similarly, if you're looking for NLP, again, there are, if I have to pick one sub area of machine learning and deep learning where there are most roles, it is NLP. There are fewer roles, especially in India with computer vision, but there are more roles with NLP. You should certainly know basic vectorizations. You should know basic pre-processing, cleaning of text data. You should know word-to-vec, how it works internally, right? You should certainly know more advanced featurizations of text like BERT And of course, the internal architecture of BERT, because that's what is being used more and more and more. Again, Word2Vec used to be the sweetheart in NLP. Now slowly it's all moving to transformer-based featurizations. Okay, of course, you should know basic stuff like TF, IDF, all that you should know. I'm covering all of that in pre-processing. These are the basics that you should at least know for a career in NLP. Now comes to productionization. Productionization, there is no end to how much you can learn. But the bare minimum you should know is, how do I productionize my model using a simple API? How do I deploy an API, at least in one cloud-based system? You pick any one of them. You pick AWS, Azure, pick any one of them. Again, it's impossible to be an expert in everything. For example, I have worked on AWS extensively because I worked at Amazon. I did not work in Azure and GCP. If I go to an interview and somebody says, hey, I worked on them briefly, but I'm not an expert at them in any way. So if somebody says, hey, how do you deploy your API in, let's say, Google Compute Platform, which I've used the least, I've used even Azure to some extent, I would say, hey, I know how it is done in AWS. I'm sure there will be some equivalent in Google Compute Platform, right? So knowing at least one of them, or even some platform as a service like Heroku, right? So at least knowing one of them is good enough, right? At least knowing one of them. You don't have to be expert in all of them, because it's impossible for anyone to be expert in all of them. I've seen engineers with like 10, 20 years of experience who can't be experts in all of them. They can only be experts in some of them, right? So these are the bare minimum, you know. Of course, if you want to learn more, okay, there is all this, there is Docker, Kubernetes, right? And there is whole of this ML ops, right? Which is basically DevOps plus, there is a new role that is coming up, which is DevOps plus or DevOps for machine learning. Okay, where again, this sort of role is most appropriate for people who are already currently DevOps, who learn machine learning, who understand the machine learning life cycle, who understand about machine learning training, right? So for people who are already DevOps engineers, if they can pick up machine learning, there is a new role that is coming up, becoming more and more popular, called ML ops. But there is no end to it, trust me. There is no end to productionization, because this is constantly evolving field. Because I can talk about productionization on, let's say, an Android device. There is no end to it. But this is the bare minimum that you should know. Bare minimum stuff. You should know basically how do you translate your code that you have in IPython notebooks into APIs. How do you deploy them? Basic stuff you should know. Most importantly, try to build a portfolio of projects. My suggestion is at least have 2 or more projects. Try and solve 2 or more problems. You can pick datasets from Kaggle. You can collect your own datasets, but try to do them end to end. When I say end to end, everything from data acquisition to productionization of the model on a cloud-based platform. This will help you enormously. And amongst the 2 or more problems that you want to solve, you can get tons of problems from Kaggle. Don't worry about it. From every field, there are datasets that you can publicly access and build something on it. My recommendation in 2020-2021, as we are nearing 2021, is at least pick one problem with NLP. That's what we strongly recommend. Because the need for data scientists and machine learning engineers who know NLP is only increasing, because this is the most widely available data that we have. Okay, at least one problem with NLP. Rest of them, you can choose some problems from your domain of expertise, etc. Very importantly, please write a detailed blog. This again, I'll show you some. Again, we have done a live session, which I'm providing a link here, on a bunch of portfolio projects that you can do based on your experience. We discuss about what types of problems you can solve as a college student, what types of problems you can solve as a 10-year experienced professional, right? And in these problems, suppose imagine you are using a deep learning model. Okay, let's assume you are using YOLO v3. I'm just making this up. Okay, if possible, at least implement one such algorithm from scratch instead of using a pre-built code. The reason I am recommending this is because through your blog and through your portfolio, you can showcase, again, what is the purpose of this portfolio? To showcase your skills to recruiters. Try and implement at least one, but as much as possible from scratch. Instead of using YOLO v3's existing code that the authors of YOLO v3 gave you, it's a very, very nice model. Try to implement it using TensorFlow or PyTorch, whatever library you want. Try to implement it from scratch, because then you understand how this algorithm is working internally. And we have seen a lot of students who have done this, who have cracked interviews left, right, and center. Because this portfolio project will be there at the top of the resume. And the interviewer says, hey, Interview will say something about YOLO V3. Then the candidate will immediately say, hey, I implemented YOLO V3 from scratch. Here is my blog, here is my code, here is my GitHub profile. Okay, so I talk about it extensively in this live session, which I've already done in the past. I'll share this document where you'll get all these details. Now you might wonder, hey, how do I do all of this in 6 months? Okay, again, I'm assuming, again, this is from our own data. We see a lot of students completing in about 6 to 7 months. Of course, the most important thing here is the effort. So we see students who are average, not brilliant, not below average. The average student who puts in anywhere from 12 to 15 hours a week, roughly 2 hours a day, give or take. Those students, this is a rough timeline that we see, right? Python and SQL, maximum 1 month. Again, don't get stuck in any one concept. Keep moving, because while you learn the basics of Python and learn some of these, you'll get a lot of Python practice when you're implementing the classical machine learning algorithms from scratch, when you're implementing some of these math techniques from scratch. Don't get stuck to one thing. Keep moving. That's very, very important. We see some students who are like, hey, I finished Python, but I'm not an expert. You will not become an expert in 1 month. Once you learn Python, you'll become better and better at it as you're implementing a lot of techniques that you learn in data analysis, machine learning, deep learning, and while you're building your own portfolio, you're going to use Python everything. So everything that you're going to learn in Python and SQL, you're going to use it throughout the rest of the 5 months. Right? So effectively, you're not learning Python for 1 month, you're learning it for all the 6 months. Similarly, all the data analysis and math that you learn, you can finish this comfortably in about a month. But again, these two are very, very important. I'm giving more time to these two topics because in the initial days, this can feel slightly overwhelming. Happens to any one of us. Imagine if I were to learn, let's say, pick a topic, right? Suppose if I have to learn economics, where I know nothing. I didn't study economics beyond my 9th, 10th class. Suppose if somebody tells me, hey, let's study economics or macroeconomics. I don't know anything in it. When I start learning, in the initial topics, I will be slow, obviously, because the initial topics are fundamental. They're completely sometimes new to me. So that's why I'm allocating more time for these initial topics, because you might start slow, but it is a persistent effort of 12 to 15 hours that is important. If you're comfortable with Python, if you're comfortable with the foundational mathematics and data analysis, rest of them will become much, much faster and easier. Right? So once you get comfortable with, again, we see students who are finishing this in 20 days, even 15 days. But give yourself a month, because these are initial topics. They might take more time for you to learn from. Then classical machine learning algorithms, once you get a hang of it, right, it becomes easier. For example, probably learning logistic regression is harder. But once you learn logistic regression, learning linear regression will become easier. Okay, learning decision trees might take little time because it's slightly new. But once you learn decision trees, learning random forest, you can do it in a day or two. Right? So don't get bogged down by the number of techniques, because once you get used to that thought process, again, these first 2 months or less than equal to 2 months will give you the mindset and the thought process for you to progress faster. In deep learning, right? Because you learned all the classical machine learning techniques, deep learning is all about using slightly advanced architectures and advanced optimization techniques. That's all. So you can actually, once you get a hang of how to understand an architecture, picking it up is very, very quick. Right? You can learn literally one architecture a day the moment you get comfortable with understanding deep learning architectures. Okay. Again, I'm not saying this will always happen. Even if you're learning one architecture in 3 days, that's okay. Learn 10, 15 architectures, you're good. Right? Then again, very, very importantly, don't wait for yourself to learn all this to start your portfolio. Once you've covered a bunch of classical machine learning algorithms, maybe a couple of deep learning algorithms, start thinking of building the portfolio parallelly. But maximum give yourself about 6 to 7 weeks to build your portfolio. Again, this portfolio building is not to be done at the end. You can start it as soon as you learn a few classical machine learning techniques and work on the side. Okay. Again, take my word for it. The moment you become comfortable with programming and the moment you become comfortable with the math, rest everything will fall in place. Your thought process improves. The first day you learn a new programming language or a new task, it's always hard. Please don't give up on your journey. Be persistent. Promise yourself in the new year. I mean, I know that most New Year resolutions never work, but at least be truthful to yourself and say, hey, I will at least spend 15 hours a week. Again, if you think you're an average student, 15 hours, 12 to 15 is good. If you're an above average student, you can do it even with 8 to 10. If you're below average, of course, you will have to spend more time. That's more a realistic estimate. Again, this is doable. We have seen students who have done faster than this also. But this is a very, very doable thing. Cool. So in a nutshell, what I wanted to tell you is this. When you're learning machine learning, data science, everything, understand the underlying math and know why you're doing something. That why is very important. Behind every equation, behind every plot, understand why you're doing it. Try to implement everything from scratch because it will improve your programming. It will improve your programming insights. It will also give you deeper understanding of the concepts. Like you can go to some of the top universities, go to Stanford, for example, or Berkeley. Look at their machine learning and deep learning courses. Look at their exams. They'll ask you to implement something from scratch. Because these professors who have been teaching for decades, they also understand that once a student implements from scratch, they understand the concept internally. This is not something that I invented. I've learned it from other top universities of the world. Similarly, understand all the cases, pros, cons, where does it work, what happens if there are outliers in the data, what happens if I have imbalanced data, all these cases. For everything, try to understand the cases. Most importantly, apply the techniques that you're learning and solve real world problems by picking problems from Kaggle. And build a portfolio to showcase your work. Because if you don't showcase your work, recruiters and others don't know what you have done. In a nutshell, these are the 5 things that I will ask you. Understand the math, know why you're doing it, implement things from scratch if you can, as many as possible, understand pros, cons, limitations, various cases of everything, apply them to real world problems and showcase your work. You are ready. It's as simple as that. Okay. So again, we have done earlier live sessions. You can just Google search for interactive interview questions. There are tons of interview questions that we have discussed for you to get a sense of it, right? Again, I link to this, but let's open up the, these are some of the concepts that I wanted to cover. I'm sure I could not have covered everything. So let's open up the discussion, general discussion. I'll try and spend as much time as possible. Okay, so cool. So now I'm back. Cool. Okay, sounds good. So let's tackle some of the questions. Just give me a minute. I'll just take a water break and we'll get started. Cool. Good. So B2 asks a very good question. Best books for machine learning. Here are some of my favorite books. Okay. So for Python programming, I like the Python official documentation. It's very good. Just go to python.org if I'm not wrong. Their tutorials are terrific. That's one place to learn Python. SQL, W3 schools, go to any online resource. There are tons of resources. Or you can book any standard O'Reilly book about SQL. That's also will do. Again, there is an O'Reilly book on Python. I forgot the name of the book, but that's also a good book. Or there is a book called Automating the Boring Stuff in Python. That's also a very interesting book in Python. Similarly, for data analysis and probability statistics, there is this book called Think Stats. It's a very simple, very applied book from O'Reilly, if I'm not wrong. That book is freely available online. So pick up that book, Think Stats. Very nice book. For machine learning, there are 2 books that I really like. One is called Pattern Recognition by Christopher Bishop and Elements of Statistical Learning. These are like 2 of the best books that I know of. These are used in almost every university as standard textbooks. For deep learning, there is Ian Goodfellow's very nice textbook. But again, deep learning is so fast moving that I tend to start reading technical blogs or I tend to read research papers. But that book is a very good foundational book. These are some of the books that I would recommend in general. Okay, cool. How much math should you know? You should be able to, so that's a good question, Gunja Om Prakash. So you should be able to derive any technique from first principles on a whiteboard or on a white piece of paper. That's the level of math that you should know. Ideally, I mean, if you know that, you're safe. You can even crack top product based companies if you know that level of math. Like for example, I could ask you, okay, can you derive linear regression from first principles? Can you derive everything? Tell me all the assumptions you're making, why you're choosing this model, why this, why that. Let's derive the whole damn thing. If you can do it, that's the level of math that you should ideally know. Okay, cool. Sufal says, tell me about how to build a profile. Again, on our YouTube channel, there is a live session called, so let me look it up. Again, I'll provide a link in this doc. So this doc has a link on how to build a portfolio. I'll share this doc with you right after the session, and you will be able to see that. So there is a dedicated 2-hour session on what sort of problems to solve based on your experience, based on your background. It's a very detailed 2-hour session on how to build a machine learning portfolio of projects for career transition. That's the title of the live session. You can find it on our YouTube channel. It's publicly available. So cool. Hanumant says, how to answer if an interviewer asks explain CNN. It's a very nice, very simple question. It looks very simple. You can talk about why we need CNNs. Why can't we just use MLPs? First, very important. What is a convolution operator? Why are we using a convolution operator, and why does it improve the results as compared to a standard multi-layered perceptron? You can leave there and you can say, hey, this is the basic intuition or basic reasoning on why we have a CNN. If you want me to go into more details, I can tell you about various operations we have in CNN, like max pooling, so you can keep going into the depths of it. But give a quick 2-3 minute overview on why we need it, what are the key components of a standard CNN, and what operations do they do, like the convolution operation, etc. And ask them, do you want me to go into more details? That's good enough. So okay, so there is a question about the online 1-year diploma with UOH, right? So it's a very good question, Arvind, that you asked. So this program is starting in January. So this is a program we are very fortunate, and we're very excited to do this 1-year diploma in AI and machine learning with University of Hyderabad. So the fundamental difference between our applied AI course and the 1-year diploma in AI machine learning would be the diploma in machine learning in AI is co-conducted by University of Hyderabad and us. So whatever I talk today will be there in that course without doubt, but there will be slightly more academic rigor. So we'll go into more mathematics, right? Then, I mean, in some concepts, if not all the concepts, because there are some very senior university professors who are like dean of mathematics department, etc., who might be taking some classes. There are also industry professionals who will be co-instructors in that. So as an academic course, it tends to be slightly more mathematically and academically rigorous. So you'll have standard exams, all of that stuff. But in terms of coverage, I think what we'll have is very similar to what we have in the applied AI course. Again, the reason UOH is conducting this diploma in collaboration with us is because what we bring to the table is the real world applied aspects. So I am the primary instructor for all the courses, but we have co-instructors who will be taking some sessions. So we will continue to maintain the academic rigor of any university program along with all the applied aspects that we cover at applied AI course. But all the grading, everything will be done by University of Hyderabad through midterm, semester end type of exams. So that's the fundamental thing. You'll gain the knowledge in both places, whether it's applied AI course or PG or the online diploma course. Again, remember the online diploma course is a purely academic course with 1 year. So the applied AI course, you can finish it in 6 months. Nobody is stopping you. So one student asked, why is the diploma program 1 year? Why not 6 months? Because University Grants Commission, which is called UGC, which is under Government of India, has stipulated that all diploma programs should be at least 12 months. Anything less than that, it's not recognized by UGC or Government of India. So we have to stick to their norms and processes, because we want this to be both academically rigorous and recognized by Government of India, right? So that's the reason it is. So applied AI course is more self-paced. You can finish it in 4 months, 6 months, 8 months, whatever time you want. The diploma program is more academically rigorous, more academically focused, I should say. In terms of mathematical rigor, right? Even in applied AI course, we cover most of the mathematical rigor that is there. So it will be more academically focused. Cool. 1 second. Okay. One second. I didn't understand. So Naman says, I want to do a master's in AI and machine learning. This is beneficial to do the course. Yeah, surely. I mean, we have a lot of people who pursue MS in US or MTech at IITs, IISc. We have a lot of students who are master's degree students at IITs, IISc, even undergraduate students at some of these places who are course participants. And the reason they take the course, some students even take the course before they start their MS program, because this will give them the foundations to perform very well in their coursework and get into internships quickly. right? So a lot of students at Indian Institute of Science, IITs, etc. take our course because it helps them, because most university courses tend to be academically focused, more theoretical focus. What they learn from our course is, in addition to the rigorous theory, they also learn the applied aspects, which is what benefits them when they go for internships or full-time roles. Cool. So Trojan has a question, which is how to pick a problem statement and perform end-to-end operations on it. So that's fairly simple, right? So for example, again, just watch that live session that I'll point to. I think, let me just look it up. It's called, okay, just give me a second. I forgot what it's called. It's called Applied AI Course Portfolio. Just a second. Projects, I think it's, okay, I just have to search. So it's called Machine Learning Projects for your career transition based on your current role. Okay, so that's okay. So let me just mute this. Yeah, that's the title. So let me just share it with all of you. Just a second, folks. Yeah, so let me just put it here. Yeah, I'm just pasting the YouTube link of the 2-hour session that we have done about how to pick a problem, what's, again, based on your expertise, based on your experience, based on your educational background, and how to solve it end to end. End to end means everything from data acquisition, doing data analysis, doing statistical tests, doing feature engineering, building machine learning models, coming up with business problem, the metrics that you care about, doing that whole thing, productionizing the model, deploying the model, maintaining the model, retraining the model, that whole thing, that whole data science life cycle. We have another video on our YouTube channel. It's called Data Science Life Cycle. Just check that. That will tell you what do I mean by end to end. That's very, very important to think through, right? Cool. Okay, so let me just scroll down. Okay. So Sriram has a good question. So Sriram has, I like the question. So he says, there are roles like full stack data analyst. How good are these roles? Is it good to join some startup companies as full stack analyst? Again, this title is borrowed from full stack development, right? In software engineering. So where people develop both front end JavaScript, back end servers. So when somebody says a full stack data scientist or a full stack machine learning engineer, they're saying, hey, we want somebody who can do everything from data cleaning to model productionization. That's what they mean. In a nutshell, that's what, again, it's just a fancy title. What it means is sort of like a machine learning engineer. If I have to put that into one of the roles, it's closer to a machine learning engineer or sometimes even a data scientist, because data scientists do productionize models, right? So a full stack data scientist or a full stack machine learning engineer basically means somebody who can do everything from data analysis, data cleaning, data acquisition, obtaining the data, scraping the data. Again, we have another live session. It's called how to scrape data from websites using Beautiful Soup and other libraries, right? So how do you do that? Up to productionization of models using APIs, you're basically microservices architectures, etc. That's what they mean. So Rohit says, okay, so let me answer this question also. Rohit says, I'm deciding to, again, folks, I'm very sorry. I'm not able to answer every question. I'm just scrolling as fast as I can. Pick one question and try to answer it. I'm just doing it more randomly here. Okay, so cool. So Rohit had a question which was, I'm planning to do the theory first and then the assignments in Applied AI course. We have students who have done that successfully. There's nothing wrong with it, but we would say do them like in the order that are there. That's sometimes beneficial, right? I'm not saying that's the best way. That way you'll get a hang of things instead of just binge watching them. But we have had students, as you might have seen in some of our success story videos, right? Some students just binge watch like Netflix series and then finally sit down and write code. There's nothing wrong with it. That's your call. Okay, we will leave that decision to you. So Abdullah says, what algorithm are you applying to pick a question random? Okay, so there is one very nice question that just caught my eye and I missed it. Okay, so this is Shreyansh. He's saying, is knowledge of framework like Django, Flask also required in the field? You don't require to know Django. Django is like a big full-fledged backend platform, right? You don't have to know Django. Even if you know how to build a simple API using Flask or using Fast API, even using Django, no problem with it. If you know how to build an API, if you can expose your model through an API, that's good enough. You don't have, again, Django is a massive platform. I can't claim I know Django. I know some parts of Django because we've used it for some components of our course. but I don't know Django fully. It's only foolish to say if I know Django, right? So I know, again, it's very important as engineers, right, for us to pick up whatever is needed when it is needed. For example, let me give you an example, right? So let's take Django. So I know some parts of Django. I know how to build an API in Django because we've used it for some components of our website. There are some components that I don't know. If there is a need for me to learn it, I will just read the documentation because I know Python programming. I know the basics of how APIs work, how basic internet works. So I will just read the documentation, pick it up. And that's the skill that we all need to build, right? So, so Hemant says how to keep practice on deep learning frameworks. I think if you mean how to become good at TensorFlow or PyTorch, take a model, implement it from scratch. Take a GAN, simple GAN, or take a transformer model. Again, we did this in one of our live sessions where we took a transformer, implemented a transformer. It's fairly like cumbersome, takes a lot of time in terms of code also. I think we did a live session for about 4 hours, 2-hour sessions, where we implemented a transformer in TensorFlow from scratch. And it was a terrific experience because first you understand how a transformer works internally. It's also great practice for TensorFlow code. Like, it was a great practice for me also. When I was preparing for these live sessions, I said, okay, let's do the whole thing in TensorFlow. I mean, it was a good, again, the best way to practice any deep learning framework is very simply pick a model, implement it from scratch. Nothing beats that. Cool. Okay, so Arun has a question. He says, I have 10-year experience in mainframe and Java support. Can I transition to the ML role? Yes. So what you should certainly look for is, again, let me give you a context. I was interviewing one of our students just now. I think 1 hour before this session. I was just talking to him, and he said he has 7 years experience in technical support. Okay, he's a senior technical support engineer. So technical support, not even coding. Okay, he has not coded extensively. He finished the course successfully in 1 year. Now he's joining it as an assistant manager for a data science team. So he has successfully transitioned. So we have, and he's a BSc math with MCA, if I'm not wrong, with 7 years experience. So there are people like that with 7, even more years of experience, sometimes even from non-technical fields or somewhere near technical, but not exactly coding and all that stuff. So it's very possible it all requires you to put more effort than somebody who already knows coding. That's the key here. You can learn. You can certainly learn that. So Ashok, if you have 10 years experience in mainframe or Java support, you have to brush up. You have to become, again, I'm sure that as a mainframe engineer, you have written COBOL code. You've written, I'm sure, general code. So if you have the coding mindset and if you're willing to put in the effort, I think you can successfully transition. No doubts about it. 1 second. So 1 second. What is this question? I just moved too quickly. 1 second. So I am a second year student in BTech. Should I start from applied AI? Shivam, my suggestion to you is you are currently in second year, right? My suggestion to anybody who is doing your BTech, right? BTech first year, second year, try to become good in programming, become good at data structures algorithms, because the moment, and of course, become good at the maths that you learn in engineering mathematics. You can start it in second year, but third year is also a good time for you to start. Again, if you start in second year or probably in second year, second semester, as a CSC student, I'm assuming you know basics of programming. Try to become good at programming. Try to become good at basic data structures algorithms. Then taking the course probably in a second year, second semester, or third year, first semester is a very ideal situation, because then you have the basics. You can move very, very fast in the course and strive for internships right after your third year. That's a nice path that you can follow. So Ryan says, has PyTorch taken over TensorFlow and Keras? I mean, what do you mean by taken over? Again, PyTorch is very, very popular with researchers. So if you look at a lot of research publications at top conferences, journals, more people use PyTorch. But if you look at production environments, I think they're neck to neck, right? There is no, again, let's not get too caught up on a platform or a framework or a library, because they come and go, trust me. Okay, we have TensorFlow, PyTorch today, tomorrow there will be new thing. What is important is pick any one of them. All of them are fairly good, fairly mature right now. For example, in PyTorch, can you train a model and deploy it on an Android phone? I'm not saying it's impossible, it's much harder than doing it in TensorFlow. Okay, again, remember TensorFlow is being used by companies like Google and maintained by thousands of open source contributors. I'm not saying PyTorch is bad or PyTorch is good. Pick any one of them, that's perfectly all right. Pick any one of them. Right now, in the research community, PyTorch is more popular, but in production, they're neck to neck. And that's perfectly okay. Nobody can be perfect at every library, trust me. Like, it's only foolish to think if you know NumPy, everything inside out. No, I've been using NumPy for almost 15 years. I can't claim that I know everything in NumPy. I only know the functions that I need, that I use. If I forget something, I go read the reference manual. Right? Same with this. If you know the concepts, picking up a new library is just a weekend's work. Or suppose tomorrow there is a new library. Because I know about the computational graph, I know about the concepts in TensorFlow, for me picking up a new library is just a weekend's work. Okay, cool. Is the placement scenario different for diploma and applied AA course? Yes. So at applied AA course, we have the job guarantee or money back program, because we want to be completely aligned with student success. In the case of the diploma with University of Hyderabad, because it is under the UGC, under Government of India, it's a government research university, by the way. So they will not have a job guarantee or money back program. As far as the placement assistance is concerned, it will be exactly the same placements team that we have. We are just increasing the manpower, hiring more experienced folks, hiring new folks, hiring more HR folks to help us with our placements team. So it's only going to get, so everything that we have in the applied AA course in terms of placement assistance will be there for students who graduate at the end of their UH. Of course, I mean, the most important thing here is we expect you to have good grades, good marks in the UH diploma, right? Please try and work. If you're if you've got an admission letter, again, I think the university started sending admission letters for the last couple of days or so. As and when we get an admission letter, we're forwarding it to all of the students. Please commit yourself to putting in those 12 hours of effort every week, right? Because that's very, very important. Again, remember, University of Hyderabad has a very rigorous academic credentials. So the exams will be conducted by them. We will give you all the mentorship, all the education you need, but you have to perform well in their midterm and semester end exams, right? So as long as you perform well, there is nothing wrong with it. It's great for you. Okay. Very interesting. So Sagar has a question. It's a nice question. Is it good to do an MS in data science and AI from foreign countries to get a high and good package? Again, one of the biggest reasons why Indians go and pursue MS in the US is not because they're passionate computer scientists or passionate about computer science, because an MS in US in any field gives you the level, what do you call it, the permission from the government to work in the US for the first 3 years or 2 years, whatever that is called, right? So surely, if you're going to US because there are more job opportunities and the compensations is high, obviously you'll get more comp, no doubt about it, right? I mean, just in pure dollar amount term. Cool. So Neeraj has a question. Can we do a live session on self-supervised learning? Sure. That's a topic that I'm very much looking forward for. Very interesting topic. We'll surely do that. Again, parts of it have been covered in other models that we did, but we'll surely cover that. Okay. Ankita has a very nice question. I really like her question. So she has about 5 years work experience in ETL, right? Like standard database pipelines, etc. What is better for me, a data architecture role or a machine learning engineer role? Both roles are good for you, actually, to be honest with you. Again, a data architect role is a easier transition for you, to be honest with you, because it's very similar to what you've been doing. From an ETL engineer with 5 years experience, data architecting is like it's like C and C++, right? A machine learning engineer role is as good as a data architecture role, but with more learning that you have to do. So it's a career choice that you have to make. Do you want to be in data architecting role in for the next 5 years or so, or do you want to move to machine learning? Again, if you are good at it in data architecting, you can get the same compensation as machine learning engineer. Again, at the end of the day, in any career path you take, it is your excellence that matters. I have seen software engineers who are brilliant, like literally brilliant, right? So I've seen data engineers who are brilliant. I've seen data architects who are like extraordinary in my own career. I've seen full stack developers who are brilliant. I would not suggest them to move to machine learning. I would say you become better at your own game because you're already so damn good. Become better at it. Like when I was at Amazon, some engineers in my team used to say, "Hey Verma, I want to become machine learning engineer from a software development engineer." I would ask them only one very simple question. You can, I'm not denying that. But you have two paths now. From a software engineer, you can become a senior software engineer or you can become a machine learning engineer. If you're really passionate about math, right, take the machine learning engineer path. If you think I don't have time, I don't want to put in this much effort of time, then go through the senior engineer path. There is nothing wrong with it. So there is great opportunity even in sales, marketing, business development. There are phenomenal people that I come across every day, HR, finance. So whatever you are, you can excel in the same role, no doubt about it. But going into machine learning as an emerging field, there are more roles, there is more opportunity to grow, and you'll have the early mover advantage. Cool. So, okay. Tahir has a question. For a non-technical guy, what sort of role is best? I wanted to actually answer that question. I forgot in my notes. So for somebody coming from a non-technical role, it is easiest to crack the data analyst role. Okay, it is going to be the easiest. And we have had non-technical folks who have also cracked data scientist roles. Pure machine learning roles or applied scientist roles are less probable. I'm not saying impossible, less probable. A more realistic thing that you can look for is join as a data analyst, work in a data analyst role because it's easier to crack, because the hiring bar is also slightly lower. First crack that role, excel in that role, and then jump to a data scientist role. That's what I would recommend, especially if you're coming from a non-tech background. A data analyst role is the most apt role for you to get into. Again, we got some emails about students asking, hey, I have a career gap after my BTech, what should I do? If you have a career gap, again, always justifying career gaps are hard. We have recommended this multiple times in multiple live sessions of ours. Don't quit your job to learn machine learning. If you cannot balance your job and machine learning, just leave it. Continue in your job. When you get time, then prepare machine learning. Because a career gap is often very, very hard to justify. We recommend everyone not to take that gap. But unfortunately, imagine if you have a gap. First thing, get into an internship role also if you can. Get into some role to show, again, we have had students with 2 years, 3 years career gaps. What we personally recommend to them is get into an internship role first. Very often what we've seen is these students are hungry and they're hardworking. They get into an internship role, within 3 to 6 months, they get a full-time role. Or they jump to a company. If that company doesn't offer them a full-time role, they use that 3 to 6 months experience and jump into a full-time role. So if you have a career gap, if you get a full-time role, great. If you don't get a full-time role, it's perfectly okay to join an intern role and then jump full-time. Because for internship role, the company is also less critical. It will give you an internship easily than a full-time role. Cool. Okay, so Aditya, Aditya Patak has a very nice question. I want to answer that. Where to study machine learning and deep learning for free? Good textbooks. I mean, they're very good. Trust me, if I were to learn machine learning on my own, the best place I would do is from the textbooks that I was telling you, right? Pick any good Python programming from O'Reilly. Pick ThinkStats, which is freely available online. I think they've opened, it's from Greenpeace publication. So ThinkStats to learn basics of statistics. Pick pattern recognition, Christopher Bishop, or this is slightly mathematically intricate, but you'll get a gist of it. Don't worry. Okay, deep learning. These standard textbooks are, I think, one of the best sources I know of because they have both mathematical rigor, mathematical depth, and if you just implement all these stuff from scratch on your own, there is nothing that beats that. Again, look at it this way, right? Where do all the top universities do? All the top universities use these textbooks as textbooks and reference books in their courses. They're not foolish, right? These are people who have been teaching, who have been educating people for decades. So that's one of the best sources that I know of. Okay, Mukesh says, are there data science jobs in Kolkata? Much fewer, to be honest with you. They're much fewer than in Bangalore, Hyderabad, Pune, or Delhi NCR, right? Much fewer in Kolkata. There are some even in Mumbai. So Lakshit says, can we get applied scientist role as a fresher? Yes, in product-based companies, yes. We've had some students of ours who have cracked applied scientist role at the top FANG-like companies or equivalent companies as applied scientists, yes. The bar is just higher, that's it. And these are typically people who are very, very strong in math, fairly strong in math. Okay, so Rishabh, very good question. What do you mean by first principles when deriving algorithms? Very nice question. I'm happy you asked that. So when I mean first principles, okay, let me ask this question. Let's take a question from probably our high school days. You have Pythagoras theorem, right? Everybody knows Pythagoras theorem, right? You have a right angle triangle, this square plus this square equals to this square, right? It's called base and height square, base square is hypotenuse square. Derive it. We all did it in high school. We all have forgotten how to do it. When I say from first principles, derive it using basic mathematical concepts. That's what I mean. Again, you can prove the Pythagorean theorem. Again, you can't use trigonometry to do that because trigonometry is based on Pythagorean the Pythagoras theorem to some extent, right? You can't use trigonometry to prove that. Okay, so you can do it using simple geometric construction of squares and rectangles and things like that. So that's what we learned probably in our 8th or 9th class, if I'm not wrong. Similarly, when I say derive these machine learning algorithms from first principles, you can say for linear regression, okay, what do I want to do? I want to fit a hyperplane. Given some data, I have y's, I have x's, I want to fit a hyperplane. What is the equation of the hyperplane? Write that. What does each of the pieces of the hyperplane mean? Okay, if I want to fit a hyperplane, what is the optimization problem I have to solve? Why is this loss the right metric? How do I regularize this model? So that's what I mean when I say build it from first principles. Okay, so that's the core idea here. So okay, space clones, I don't know, I think that's an Elias. He or she says, can we complete entire applied AI course in 2 months? I think that's less probable. No. So I mean, we have had students who have completed in 3 months also, but 2 months is, unless you already know a lot of machine learning, you already are very comfortable with mathematics and programming, it's hard to do it in 2 months. So I won't recommend that. Realistically, 6 months is a good time for you to complete it, right? Cool. So Kirandeep asks, does freelancing in machine learning increases in the upcoming years like web development? Could be. There are already some of our folks who do some freelancing work, some of our students also doing freelancing work. But I think one problem in machine learning freelancing would be sharing of data. Companies are a little reluctant to share their data publicly with a non-employee. In web development, they just have to give you the requirements doc and you design the whole website. It's easier there. But people are very, very reluctant to share their large amounts of data publicly with others. So freelancing has a scope, no doubt about it, but I don't know to what extent the privacy concerns and data secrecy concerns of companies could play a role there. Cool. So Naman asks, do you have plans for blockchain? Not enough. Not in 2021. Cool. Amit has a very good question. What expectation from a 4 to 5 year experienced software engineer for career transition? First and foremost, as a 4 to 5 year career as a software engineer, they would expect you to be very good in programming, fairly good in concepts like multiprocessing, multi-threading, handle all the boundary cases, data structures, even sometimes a little bit of object-oriented programming, right? Because you've been in this field for 4 or 5 years, right? So they expect you to be reasonable with object-oriented programming also. That's one. Number two, the expectation on the machine learning front is more or less the same, except for the scientist role. They expect you to know the underlying math, Again, for people with your sort of experience, one very popular question here is they'll take an algorithm and say, hey, how would you implement it using multi-threading or multiprocessing in Python? Right? So that's a very common question asked to people who are coming from 4 or 5 years of software engineering experience to machine learning. Because in that question, the interviewer can understand your depth of understanding of the machine learning technique and your ability to apply your prior experience to machine learning, your software engineering experience. That's one. In terms of probability statistics, everything that I told you will be considered. Again, depending on the company, the complexity of problems, the hardness of problems will increase as you go to top product based like companies, obviously, right? But broadly speaking, you would have probably more rounds of programming, probably more rounds of data structures, algorithms to some extent. Surely some of your questions will focus more on productionization of models, because with 4 or 5 years of experience, you would have spent time productionizing your code, right? So there'll be some questions on that front also. Cool. So Aditya asks, will the course content of diploma program similar to applied AI course? There will be some overlap, but they'll not be exactly the same, right? Because it's an academic program, right? So again, all the syllabus of the diploma with UOH has to be approved by University of Hyderabad's core committee behind the diploma in AI and ML program. So we have already worked with them. Most of the syllabus is more or less ready, but there will be some edits as we go. So it will not be exactly the same. There will be some overlap. There might be more academic rigor in the university program. Cool. So very interesting. Harsh is a BSc in math and pursuing MCA. You can surely pursue, Harsh, the diploma program in AI and machine learning from University of Hyderabad, because by the time you finish your MCA, or probably by the time you're in your 3rd year of MCA, you'll also finish the diploma, and that will give you the career readiness. So again, since you already have a BSc in math, I'm sure you're comfortable with some basic math for sure at undergraduate level BSc. So it's a match made in heaven actually. So math background, currently doing masters in computer science like an MCA, pursuing the diploma in AI machine learning is like a perfect match. Okay. For data analytics project, what can we do to acquire the data, like simply downloading from Kaggle? Alan, very good question. Alan David has a very nice question. So, okay, the simplest and the easiest way is download it from Kaggle or some other source. Again, that's trivial, right? To be honest with you. The best way is if you can obtain the data yourself. So I'll give you the levels of data acquisition. Download from Kaggle is the simplest. It's a joke, to be honest with you. Okay. Second, scrape the data or obtain the data by calling APIs. Okay, we've done a live session on that. I think it's publicly available also. We have shown you how to acquire data using Bing Search API, using Amazon Products API. You can get all this data using APIs to fetch data. That shows a little bit of programming maturity, ability to use web APIs publicly available. Third, scrape the data using again, try to write as much code as possible. You can use Selenium, you can use Beautiful Soup, all of these things. That's the next level. Third, go out and fetch the data yourself. For example, I'll give you an example. One of our students, he wanted to build a self-driving car type of system for Indian roads. So he took his smartphone, he stuck it to his car windshield, and he drove it on Indian roads. Okay, and he also put a camera to see how much his wheel is turning. So we have one such case study with US data. So he went ahead, put physical camera, your standard smartphone cameras, collected the data, went ahead, built a simple CNN model, nothing complex. In all of his interviews, he joined in a very good role, very senior role. I think he's somebody with about 6-7 years experience. So very interestingly, all of his interviewers said, hey, this data acquisition that you've done is terrific, right? Most of his interviews were about data acquisition, not about deep learning as much, because he has done something unique. So in terms of data acquisition, downloading is trivial, nobody cares about it. Use publicly available APIs to fetch it, that's better. Scrape the data, the next best. Fourth best is go out and find ways to fetch the data yourself in an ingenious manner. That is unbeatable. Okay, cool. So Adhirup says, I have applied for, again, Applied Roots, for those of you who are seeing this live stream, Applied Roots is just a parent website where all of, again, earlier we are putting each of our courses at one place. So we thought, let's put everything under one umbrella term called Applied Roots. And the name itself is because we focus a lot on applied aspects in every course that we teach. And Roots because we want the foundations of your learning to be more applied in nature, more fundamental in nature, more foundational in nature. That's the reason for the name Applied Roots. Applied Roots is also our website. The diploma program that you applied for is run by Applied AI course itself. Okay, so 1 second. So I just scrolled it and missed the question. I almost half read it. Okay, I will move on. Okay, that's okay. So Sidhu KM, he says, I have 2 years experience with masters in aeronautical engineering, currently doing data science course. How can I showcase my experience while searching for a data science job? Can you attach a list of companies to apply? Sidhu, there are 2-3 directions that you can look at. Try to pick up data sets from Kaggle, from engineering, mechanical engineering, from machine failure. So there are some of those data sets. Or there are also some data sets from fluid dynamics, because I'm sure you would know what fluid dynamics are and things like that, right? So there is a lot of recent research in the last year or so on how to apply deep learning systems to solve complex fluid dynamics fluid dynamics, basically PDEs, your partial differentially complex PDEs. So you can do your case studies on that. Also do a case study, at least one of them in NLP. The companies that you could look for are companies like Boeing, companies like ABB, right? ABB, Bosch, right? All these are companies which are in that electrical engineering, mechanical engineering, maybe some aeronautics, right? So it is in that intersection that you can look at. Like the companies that come at the top of Honeywell, yeah, that's another company which works very closely in aeronautics and other areas. So companies like I know ABB works very much in, ABB is this huge, I think, Swiss giant, if I'm not wrong, which manufactures high-end electromechanical equipment. So these are the companies that you can look at for sure. Of course, there are also other local companies. When I say local, these are also giants like Tata Motors. Again, the auto industry is slightly in a slump now, but those are like Mahindra, right? All these companies are also setting up their data science machine learning teams that you can look at. But don't limit yourself only to these companies. Do some case studies in NLP. Try to get into general data science also. Don't fixate yourself just on aeronautics or electrical or mechanical engineering. It's good to be prepared for all sorts of roles. If you get something in mechanical engineering or aeronautics, that's great. But try to be more broad in your search. So Altaf asks, what is the scope or opportunities in Gulf countries? Again, I'm not very good at that because I don't have deep understanding of the market. But at least one country that I know of which is investing heavily into AI is Arab Emirates, United Arab Emirates, UAE, Dubai basically, as many of us know. So that's one country which is investing heavily into AI, machine learning and equivalent systems. So again, I don't know the job market very well there, to be honest with you, but I think that's one place where you should seriously look for. Okay. Oh, very interesting. Adhirup has a question. I'm working in infrastructure and code for 4 years. I have knowledge on Linux and Windows servers. I have Red Hat certified admin DevOps. Okay, very interesting, Adhirup. So you're a very ideal candidate for a career like MLOps. Now, what is MLOps? MLOps is the whole DevOps thing, but for machine learning, right? In DevOps, what do? We take care of the life cycle of code, right? In machine learning, so in MLOps, we take care of the life cycle of machine learning code and machine learning models. So for MLOps, your skill set, your 4 years experience is very much aligned to it. You just have to understand machine learning, understand understand the whole life cycle, understand what each algorithms do. So even if your mathematical understanding is not too deep, you're still okay, because DevOps, MLOps requires you to have even if you have a data analyst like knowledge, right? You know everything at a high level. You may not be very good into the deep mathematics. That's okay. If you understand the applied aspects, if you understand how to apply, where to apply, what happens after this, what are the problems that you will encounter here. If you know all of those intuitive details, and if you can combine that with your 4 years experience in as a DevOps or as a system admin, I think that's a nice role that you can get into. Cool. Where coding skills is more required, SDE role versus data scientist role? Surely software development engineer. For a software development engineer, the coding skills required are surely more than data scientist. No doubts about it, hands down. Okay. So Purushottam has a question. So I'm happy you asked the question, Purushottam. He says, what is the importance of knowing big data, Spark, all these things for machine learning roles? Again, these are good to know skills. These are not mandatory. Okay, if you know them, great. So in our course, we have covered about NoSQL databases. We have done multiple sessions on Spark, both at a system level as well as how to use Spark for machine learning applications and data science applications. So Spark is, if you know it, great. If you don't know it, it's not a roadblocker, because if you're strong with foundational concepts, if you know programming, picking up Spark is not very hard. And again, most data scientists, when they use Spark SQL, which is very similar to your standard SQL. So if you know SQL, picking up Spark SQL is not very hard. And very often you may not own the Spark cluster. You may not be responsible for running the Spark cluster, because very often you will have operations engineers or you'll have software engineers who are managing that for you. So knowing it doesn't hurt. It's always good to know, but not knowing it is also okay. It's not a mandatory skill. It's a good to have skill. Cool. So I'm 2019 pass out. So I don't know. I think this is an Elias. So he says, I am 2019 pass out, still not got a job. Is it possible to get ML jobs? So my suggestion for you is this. I'm sure 2020 has been a hard year for you because the whole job market took a nosedive because of lockdowns and things like that. My suggestion for you is, instead of increasing your career gap, try and first get into an internship based on what you currently know. That's what I would recommend, because learning machine learning, transitioning will take time. Why even waste the time? If you already know programming, let's say, get into a programming internship or a full-time role first, and then parallelly learn machine learning. That's what we would personally recommend. Okay. Where is this? So Sai asks, I'm doing my MTech in ocean engineering from IIT Madras. Can I switch to ML by doing my thesis in ML? That's certainly a good idea, Sai. So I have encountered people from non-CS backgrounds, but I'm sure the ocean engineering department is very heavily math driven. So since you come from a top university, if you can build, if you can become comfortable with programming, understand the math, which I'm sure, because you would have understood a lot of complex math underlying ocean engineering, learning machine learning shouldn't be that hard, right? So please pick it up, and as part of your master's thesis, if you can apply what you're doing, what you've learned in machine learning and deep learning to ocean engineering, that's great. It will surely open up doors in machine learning for you. But the skills don't change. Whether you come from an IIT or you come from Stanford, the bar only increases. I've seen this, including myself. When I go to a top university, I tend to ask harder questions because I expect them to know it. For the same role, when I go to a more top university like Indian Institute of Science, IIT, Stanford, etc., I tend to ask harder questions because I expect these folks to be better in general, right? So the expectation from a top university graduate is also higher. So you have to be, your comfort with math should be really, really good. Again, because you come from a non-CS background, they can't test you much on programming. So they would rather test you more on your math stuff. That's where you have to be really good at. Cool. So Sriram has a question is, what are your thoughts on the BSc online degree from IIT Madras? Again, I'm not sure how it is. Again, I've heard about it. I know how it's being operated. We'll have to wait and see how this pans out. It's too early for me to comment on it. I mean, it's a nice idea, no doubt about it. But how does it work out? We'll have to wait and see. Okay, this is a good question, Gaurav. Should I join a startup or a big MNC in data science or machine learning as a fresher? I'm from mechanical engineering background. Uh, there is nothing wrong with any of them, but my recommendation always is don't pick a company, pick a team. Whether you join a large company or a small startup, ask yourself, especially early in your career, right? It is important that you have challenging work. That's very, very important. I can't, like at Amazon, when I joined, I was one of the earliest machine learning scientists in my whole organization. That gave me enormous amount of learning experience. When I joined Yahoo Labs, fresh out of college, it was a very mature organization with phenomenal engineers and scientists. I did not get much to learn. So whether it is a large company or a small startup, try and pick a team where you will get to do things in the next 1 year. You will get to build things from scratch if possible, because that will be enormous amount of learning. I can't say, I mean, that's better than joining a well-established team, because you may not get to do great work there. So always I would favor a team which is early, which has a clear direction for the next 1 year, where I would get to learn a lot, irrespective of whether it's a startup or a big company. It is more likely to find such teams in startups than in bigger companies. You have to get lucky in a bigger company to find a team like that. In smaller companies, there is a higher chance you find such a team, and hence, again, it's a pick and choose. Assuming the compensation is same, I would pick at least early in my career, even later in my career actually. I'm a type of guy who wants challenging work, so I would pick that any day. Cool. Yes, Shubham is asking, can you please provide the links? I will provide the whole the PDF that I discussed. I will post it in the description section in a while. Okay. Very good. So Aditya has a question. So where is that question? You put all dhamaka stuff. Okay. So he's saying I'm writing my GATE exam now. So which is better, going to Indian Institute of Science or IIT, doing my masters there, or pursuing applied AI course? My suggestion here is going to a top university will open up lots of doors for you. Let's be realistic there. Okay. So my suggestion for you is as follows. Why don't you crack GATE now? You're in your third year, right? Crack your GATE now. In your final year, learn AI machine learning, try to get a job. Again, this is something that we told all of our GATE students also. Right after BTech, if you're getting into Amazon or Google or Flipkart or Facebook or any of these companies, right, or Microsoft, don't bother going for a master's program unless you want to become a professor. You want to do a PhD. I mean, there's no point in it, because at the end of it, if job is your goal, you already are getting the job that you would get after IIT or ISC, right? Realistically speaking. So my suggestion to you is prepare for GATE. It will make your foundations very strong. It will make you a good computer science engineer. Crack GATE. If you crack GATE, great. If not, you can always pick up the AI course after you graduate, after you go to a job, or even we have a lot of students from IISc and IITs who pursue our courses because they want to have a leg up in competition in their job search or in their job interviews. So either of it is all right. So Arvind says, what are applied AI plans on AI topics in 2021? We are planning to cover more cutting edge topics in our live sessions. We are planning to conduct more interview sessions in our live sessions. For example, this is something that our students like a lot, and it's also beneficial to the students. So we would pick up each chapter or each module, and we would have an interactive session where we will solve problems together, where I'll ask pointers from students and things like that. Right now, we are doing this interview session type of setup for model productionization. Like last week, we picked a couple of case studies of ours and we discussed pros and cons of each productionization option, because there is no one apt productionization option, right? If you suggest me something, I can give you a counter example where that won't work, and I'll keep asking you follow-up questions, right? So I think we'll focus more and more on these interactive interview question sessions while covering more advanced concepts as they evolve. So one thing, I mean, there are a bunch of concepts at the top of my mind. So surely we'll cover all this. Again, PyTorch is something that probably we'll cover very soon. So there are some of these, again, we may not be able to go full deep into PyTorch, but we'll give an introduction so that you can pick it up and run with it. Cool. Very good. So Javed says, I have 3 years experience as data scientist in startups and small size companies. What should be my approach to get into big MNC and top product based companies? Very simple, Javed. You become better in programming, become better at math, because given your startup experience, if you apply to some of these companies, you have a decent chance of being asked to come for a screening test or something like that. You have to prepare well for it, because most companies for data science roles, they have, at least Amazon like companies, they have a screening test, then they have about 5-6 interviews. So first prepare thoroughly and then start applying for these companies. It is likely for you to get a call because you already have 3 years experience at interesting startups. So when you get a call, be prepared to crack it. That's all I would recommend. Okay. One second. So for ML Ops, what is the, so this is from, okay, this is from one of the students, which is from ML Ops. What is the approach should I follow? Can you make a session on it? Sure, Abhirup, probably we'll do a session on ML Ops. I mean that, or I'll put out a video, or probably we'll do a live session on ML Ops. I'll do that for sure. No problem. So what level of coding is needed for a data scientist? Very nice question, Vikram. That depends on the company. So let me give you some examples, right? Take Amazon. Okay, take Amazon or FANG, the top product-based companies, right? They would expect you to be able to implement an algorithm with reasonable space and time complexity using inbuilt data structures. They're not expecting you to be an expert in data structures algorithms. For example, they might ask you, how do you implement pandas.merge, which is like a SQL join operation, right? They'll give you 2 tables and say, merge these 2 tables, write code from scratch. Or they might ask you something like, how do you implement X power Y, the examples that I gave you, right? So, or they might ask you, hey, I'm giving you some 100 numbers, find the kth smallest number. How efficiently can you find it? So there will be some focus on time and space complexity at top product based companies. One level below, it will be easier, like how do you, slightly easier questions. And even these questions are not hard. If you know how to write for loops, if you know the basic inbuilt data structures like hash tables or dictionaries in Python, lists, etc., this is fairly straightforward. These are some of the harder questions that you can expect, or some of the questions you can expect for data scientist roles at the top companies. And some companies might just give you a task for data scientist roles. They'll give you a data set and say, hey, do all the analysis using any library of your choice. That's more of a hands-on thing. So then you say, hey, plot PDF, CDFs, you have to know matplotlib, all these standard libraries. That's another type of interview that some companies conduct. And then what they do is they give you 2 hours, they give you a data set, they'll make you analyze the whole thing. And their interview will be, hey, why did you do this? Why did you do that? How do you interpret this plot? What do you make out of this? And things like that. Okay. So this question is about TinyML again. Do you see openings in India? Not much, to be honest with you, because we as a country are not as much into hardware development. If you would ask me about China, I would say, yes, there are options. Not so much in India, to be honest with you. That's why it has never been the focus of our, at least the job market that we see. There are very few companies who say, hey, we want somebody who is an expert in machine learning for embedded processors. We don't see that much. Because what happens very often here is, it's typically an embedded systems engineer or an embedded system software engineer will work with machine learning guy and they both will build it. Because it's very, very rare to find the talent, and the number of openings are also fewer. At least for the next year or so, I don't see that taking off to be a big role. Cool. So Yash has a good question. He says, I'm a QA automation engineer. Transitioning to data science profiles, will my experience help? Yes. So for example, as a QA automation engineer, I'm sure you know things like Selenium, right? Or QTP. So you can pick up Selenium. You can use Selenium with Python, by the way. So why don't you, I mean, in one of your case studies, you want to build on top of your experience. In one of your case studies, use Selenium or any of these equivalent tools, obtain data from the internet, right? By scraping it carefully, of course, respecting robots.txt. Fetch the data, build some machine learning models on top of that. Now, what are you doing? You're showcasing that you know machine learning. You also are building on top of your prior experience. Surely there are, you can surely transition from a QA engineer type of role, because as a QA automation engineer, I'm sure you would write some code. So it's possible even for people who don't code to transition to data science roles, but for you it will be easier. Okay, cool. So during the interview process at product-based companies, are we allowed to use Google? No. Most often no. There might be some screening tests where they might allow you to use Google, but not during the interview process. Suppose if I'm asking you something about, let's say, GBDTs or something about convolutional neural networks. If you say, hey, I'll Google it and find it, I'm like, sorry. But let's assume I give you a 2-hour task. Again, they'll tell you it's an open book task. Suppose you've forgotten a function. You can always Google search for that function and put it back. That I think most people are okay with. Okay. I'm sorry. Just a second, folks. So Neeraj has a good question. Are the roles in the industry less challenging than research? How to stay updated without doing a PhD? For example, I don't have a PhD. I chose not to do it. Because I wanted to be in the industry, learn how to get things done. So the way I keep myself up to date, because I also interview PhD students. I've hired PhD students, I've interviewed them. So I have to be at the top of my game, obviously. So a simple rule of thumb that I would suggest anybody who wants to stay at the top of their game is at least allocate 5 hours a week on self-learning. Pick up the best research papers. My simple strategy is on Twitter, I follow this bunch of phenomenal researchers in AI machine learning. I follow Google Research, DeepMind, Facebook AI Research, Amazon.Science. I follow a bunch of these labs, even university research labs. I follow university research labs. I follow top professors, top researchers in these fields. When they talk about a paper, I try to pick one paper a week and read it. Sometimes it might take me 2 weeks to finish a paper if it's a slightly harder paper. But I try to do one paper a week. That gives me 50 papers in a year. Wow, that's terrific. 50 papers in a year, if you do it consistently. Like I do almost, I think this year, I'll have to count it. I think I did something like 35 odd papers. New papers this year. Completely new papers, because I was also reading other stuff on how to teach better, I was doing something on education research and things like that, but I think I did roughly around 33 to 35 papers this year. So I'm almost on the top of my game, because I know exactly what's happening, because I read all the top papers from the most recent conferences. So if you stop doing that, you become a dinosaur in just a few years. So the reason, again, this is something that I recommend to everyone who is already a data scientist. Okay, folks, and please understand that it's impossible to answer every question in a public live session. It's almost impossible realistically. So I've tried my best, and already my throat is hurting because I'm speaking non-stop for 2 hours now. So please email us any questions that we could not answer here at team@AppliedAI-Course. We'll try and answer them as fast as possible. Okay, sounds good. Thank you very much, and have a safe year end. Again, please be extra cautious given a surge in cases in some parts of India and the world. So please be extra cautious. Please stay safe. Let's wait for a few months till the time all of us are vaccinated. And I hope all of you have a good year ahead. I hope most of you, there are like already 600 plus who are watching live. I hope all of you make a commitment and promise to yourself that next year you will spend these 12-15 hours on self-improvement. It could be machine learning. It could be anything. If you want a career transition, try to at least spend 10 to 15 hours every week on it. If you want to excel in your current career, try to spend 5 to 6 hours. If we do that, I think you will be at a much better place, and surely the world also will be at a much better place. Okay. Thank you very much. An advance Happy New Year to all of you, and a belated Christmas to everyone who is celebrating. We have a big Christmas tree because my son is crazy about Christmas trees. So yeah, thank you very much, folks. Have a good year. Please stay safe. I can't emphasize this. And thanks to everyone this was a rough year for everyone, including us. There are a lot of new stuff that happened for us. It has been a rough year. I completely understand that. I'm sure it has been a rough year for some of you. I want to thank all of our students, all of our well-wishers, everyone from the bottom of my heart, and on behalf of all of our team who has stayed with us in this year, in this very rough year, in terms of lot of things. And again, let's hope the next year is better for all of us. Okay. Thanks everyone who has attended this session, and most importantly, who have helped us throughout this year in coming out of some rough patches. Thank you very much, folks. Thank you.